Okay, hello geometry. This is going to be your last geometry lesson. It's on page 14 in the workbook, and it's on section 12.6, volumes of spheres and hemispheres. What you hopefully know already is that a sphere is like a ball, okay? It's a three-dimensional circle, if you will. So thinking about like a basketball or a soccer ball, that's a sphere, okay? Now a hemisphere would be if I were to chop that in half. So a good visual is here in example 7, where you chop off the top half of a basketball, and it's exactly cut in half. So a sphere is a full ball and a hemisphere is a half of a ball. Go ahead and write down the formulas for volume of a sphere. It happens to be 4/3 times pi times r to the third power, okay? They're very straightforward formulas. Just plug in the radius, or if you're given the diameter, cut that in half and find the radius that way and then plug it in. So the lesson here today should be pretty quick. All right, so example 5 says find the volume of the sphere, round to the nearest hundredth and label the units. So we do 4/3 times pi. Now the radius is given to us over here as 8, and then that's to the third power. It does say round to the nearest hundredth, so let's type that in the calculator. For 4/3, I open parentheses and I do 4 divided by 3 like that, times pi times 8 to the third power. And I get 2144.66. And that's centimeters cubed. And that's it. Pretty straightforward, pretty easy to find the volume of a sphere, okay? Okay, so example 6, it says find the volume of the sphere with a great circle that has a circumference of 30 pi centimeters, round to the nearest tenth. By the way, for some reason, the picture down here at the bottom of the page was moved. It should be up here for example 6. So if you need a visual for example 6, look at the bottom of your page, okay? We don't know what the radius is here. All they did was they gave us the circumference. They told us that the circumference, and you can look at the picture, the circumference around the ball, if I were to measure around the ball, I would get 30 pi, okay? So we need to find the radius from that information. Remember that our circumference formula is 2 pi r. So if we know the circumference is 30 pi, let's go ahead and put 30 pi as a replacement of the c. Set that equal to 2 pi r, and then we need to solve for r here. We've done this before. The pi's will cancel on both sides, and then all I need to do is divide the 2 away. 30 divided by 2 is 15, and that is my radius. Now I can go ahead and take my radius and plug it into the formula. So volume equals, we've got 4/3 pi times the radius, which we found was 15, to the third power. And if I type that in, okay, again using parentheses for the fraction, big number, 14,137.17. Oh, this one says round to the nearest tenth. I hate when the rounding changes, so we'll say 0.2, and then we've got centimeters cubed. Okay. All right, so that one was a little tricky because we had to find the radius. Sometimes you have to do that first, so don't ignore the information that's given to you. Work with it and then use the formula. Okay, the formula for volume of a hemisphere is 2/3 pi r cubed. Instead of 4/3, we divided it by 2 and changed it to 2/3. Okay, so it's still a very simple formula. What you could do is still use the sphere formula and then cut the answer in half. So you could use the original formula, or you can use the new one if you don't like to memorize formulas. Okay, so it says, for example 7, find the volume of the hemisphere with a diameter of 6 feet. Well, they're telling us the diameter is 6. So in order to find the radius, we need to cut that in half. 6 divided by 2 is 3. So now we can use the hemisphere formula. So we've got 2/3 pi times 3 to the third power. And we plug that in the calculator. If you put that in the calculator, you should get 56.55, and we are using feet here, so feet to the third power, feet cubed. Okay. All right, hopefully that one wasn't too bad. All right, example 8 is a little bit different, so let's work this one out here. There's going to be a lot of algebra involved in example 8. Ignore the picture. The picture, remember, goes with example 6. The jungle gym outside of Jada's school is a perfect hemisphere. It has a volume of 4,000 pi cubic feet. What is the diameter of the jungle gym? Okay, well, I wrote the volume formula for the hemisphere down because we're dealing with a hemisphere. And it says that it has a volume of 4,000 pi. So that 4,000 pi needs to be put in for the V. So it looks like this. Instead of the V, I write 4,000 pi equals my formula. And now I have to solve this equation for R. Okay? I know it looks daunting, but be careful. It's not terribly difficult. Once again, the pi's are going to cancel. And you might remember from algebra class, anytime you're trying to get rid of a fraction, multiply both sides by the reciprocal. The reciprocal is if you flip the fraction over. So the 2 goes to the bottom and those cancel. The 3 goes to the top and those cancel. And then in your calculator, do 3/2 times 4,000. It gives you a nice even 6,000. And that equals what's left, which is R to the third power. Okay. Now, you guys might remember that if this was squared, we would square root both sides to get rid of the squared. But it's not squared, it's to the third power. So what we're going to do is we're going to take the cube root of both sides. What I mean by cube root is there's a little 3 in the index of the root. On your calculator, if you press your math key, it is option 4. So go press your math key, go to option 4 for a cube root, and then you can put 6,000 in there. And that's our answer. So the cube root and the to the third power, they cancel each other out, so we're just left with R, and then the cube root of 6,000 is 18.17, and we are in feet. Now, we were solving for the radius here, so it's not feet cubed, it's not feet to the third power, it's just plain feet. Okay? All right, that is it, you guys. That is 12.6. So you just finished your last geometry lesson. Congratulations. You should give yourself a pat on the back for making it this far and doing well with it. Thank you for listening, and let us know if you guys have any questions, okay? All right. Bye.